Hello students. So today we will be doing the numericals of the second chapter of physics class 10 from the Selena publication book, which is the concise physics. So the chapter is work, energy and power. So today we'll be dealing with the numericals of exercise 2A, which is basically based on work formula and the power formula. So first of all, we will take a look at all the formulas one by one. So to start with, we know that work done is equals to force into displacement. When the force and the displacement are in the same direction, so we multiply the force with the displacement in the direction of the force. Then we take the work done to be as positive. We can use the same formula also if the direction of the force and the displacement are opposite to each other. Use the same formula, but the result will be written in negative. So here S is standing for displacement. So I am writing here, okay. Because sometimes some confusion takes place, displacement get written with D also. So I am making it clear that displacement we will writing here as S. Okay. Next formula, when the force and displacement are at a certain angle. For example, if there is an object here and the force is applied like this and the displacement of the object takes place in this way. So there is an angle between the force applied and the displacement. In that case, work done will be written as F into S cos theta. So in that case, you have to take the cos of this angle. So you need to remember the angle values for cos specifically in terms of 30 degree, 45 degree and 60 degree. Okay. So whenever angle will be given, remember to use this relationship to find out. Okay. Then we will also get in certain case work done due to the force of gravity. So I am writing here work done and mentioning here due to force of gravity. So remember, when there is a work done due to the force of gravity, the force which comes there is the weight of the body, and the weight of the body is m into g. So for force we are writing m into g, and if the object is lifted to a height of h, so h comes here. So whenever it is asked to find the work done due to force of gravity, we can apply this relationship. Okay. Now we come to the power part. You know the definition of power, it is the rate of doing work. So that is why power will be work done by time. So whatever is the work done divided by time will give you power. Okay. Remember the unit of power is SI unit is watt. Okay. Then because this power is work done by time, and we have seen that work done is force into displacement. So if I write for work done force into displacement, then the displacement will get divided by time, and you know that displacement divided by time is average velocity. So we can also write here F into V, which is this one is average velocity. Power doesn't have a direction involvement, so we can take that as average speed also. So this is a very important formula because no involvement of time is shown, and power we can get with the force which is applied with the average speed there multiplied. Okay. When we are doing these numericals, apart from the basic conversion of the units, we should also remember the SI and the CGS unit, how they are related. Okay. So here some of the conversion part I am writing here. We should know 1 joule comes as 10 to the power 7 erg. Okay. And in the unit of power, SI unit is watt, but in HP horsepower also is related, specifically to then tell the power of the engines of vehicles. You must have read it. Okay, a racing car or a bike or the other cars, what their power is. It is mentioned in terms of horsepower. So 1 horsepower is 746 watt. These two conversions should be known here. The other conversions which are there, conversion of displacement, or the conversion of the unit of force, that you should be knowing it. We will now proceed to the numericals which are there of the exercise. Okay, so you will see it one by one. All the numericals we will be seeing it. So we come with the first numerical. The numerical goes like this. A body when acted upon by a force of 20 kgf, the unit is kgf, we will require to change it to Newton, gets displaced by 1 meter, so displacement is 1 meter. Calculate the work done by the force when the displacement is in the direction of the force. So the force and displacement direction is same. And in the second case, it is at an angle of 60 degrees. So we have to consider that 60 degree with the force. And then the third one, normal to the force. It means the force and displacement are perpendicular to each other. So let us take a look at it one by one. So first of all, I am going to write here this force which is given as 20 kgf. I will change it in terms of Newton. Here G is given to you as 10 Newton per kg. So I will be taking the G value as 10. And so I get it as 200 Newton is the force. Now for the first part, the work done, we will use the relationship F into S because the force is in the displacement is in the direction of the force. So we have this force as 200 and the displacement is given to us as 1 meter. So into 1, so we get it as 200 joules. So this is our first answer. Now let us come to the second part. Here the work done formula, because it is at an angle of 60 degree, we will have to use this formula W is equals to F into S cos theta. So F value remains the same, 200, S is 1 and cos of 60 degree, because theta is given to us as 60 degree. Then we write 200 into 1, cos 60 degree value you know is 2. So 2 will be cancelling this 200 and we get it as 100 joule. So the second answer we have got. The third one, now see what it says, that when the displacement is normal to the force. So if we take that, if I say the displacement is in this direction and the force was acting in this direction, they are perpendicular to each other, so that is normal, okay? And you have studied when the force and displacement are perpendicular to each other, the work done is 0. So we can write here the work done equals to 0 directly and mention there, since the force and displacement are perpendicular to each other. You can apply this formula also and work it out. Theta in that case will be written as 90 and you know cos 90 is 0. So the answer will come as 0. Now let us take a look at question number 2, which says that a boy of mass 40 kg climbs up the stairs and reaches the roof at a height 8 meter in 5 seconds. So the height is 8 meter moved. That can be taken as displacement also. Calculate the force of gravity acting on the boy, only the force of gravity, which will be the weight of the boy, okay? The work done by him against the force of gravity. Now, due to the force of gravity, we have to find the work done. And the last one is told power spent by the boy, and we have to take G as 10 meter per second square. So let us take a look at this numerical. So first of all, the mass is given to us 40 kg. So force of gravity acting on the boy. So force of gravity we will find by M into G, which is 40, and G value is given to us 10. So that comes as 400 Newton. So we have got, this was the first part. Second part, the work done by him against the force of gravity. So the second part, for work done. So work done against the force of gravity, as I had told when I was telling the formula, I can use it here mgh, okay, or because the force is already known, I could use also force into displacement. I will try to show here work done by the force of gravity with mgh. So I am writing here mgh. So M is 40, G is 10, and the height given here was 8 meter. So into 8, so multiply 8 4s is 32, and then 2 zeros, this much joule you get. So you have found the work done by the force of gravity. Now the third one says, to the power spent by the boy. Power we know is work done by time. We know already work done as 3200 joule and the time given is 5 seconds. Okay, so you go to divide 3200 with 5, you will get 640 watt, because power we are finding, SI unit of power is watt. So this solves this numericals. Now let us come to numerical number 3. A man spent 7.4 kilojoules of energy. So it is written in kilojoule, we will have to convert to joule. In displacing a body by 74 meters. So displacement is given, energy is given in the direction in which he applies the force. So work is being done in the direction which the force is applied in 2.5 seconds. Time is given. Asked to calculate the force applied and the power spent in HP, in horsepower, by the man. So we have to find here the force and the power. So first of all, I go to write here the energy which is given. You know that energy is the ability or capacity to do work. So I can take this as work done. Okay, so 7.4 kilojoule. Okay, I will multiply with this 1000, and so I will get here 7400 joule. So this much is the work done in joule. Displacement is 74 meter. We have to calculate the force part. So number 1, I will write here work done equals to force into displacement. Work done, we have got it here as 7400. Force we have to calculate, and the displacement is 74 meter. So you will get F is equals to 7400 by 74. So that gives you 100 Newton as the force which is being applied there. For the second part, we have to calculate the power. So work done by time. Work done we already know is 7400 divided by 2.5. Okay, so this I will be getting in terms of watt. Okay, I have to convert it in terms of horsepower. So we remember 1 horsepower is 746 watt. Okay, so to solve it, I need to convert it into watt by dividing it with 746. So I will write here 7400 first. I am removing the decimal here 25. So I am writing a 10 here, and I need to divide it with 746 because I have to convert watt in terms of horsepower. Now we can reduce whatever we can reduce it over here. Okay, 5 5s are 5 2s are. With 5 I will cancel this, then 5 1s are 5, 24, 5 4s are 20, 5 8s are 40, 0. Okay, so now with this 746, we have to solve it with 2. So on reducing and solving, we will get the result here as 3.967 horsepower. If I round it off, I can write 3.97 horsepower, and this is my answer. Hope you have understood this sum, okay, regarding how to convert watt into horsepower. Now let us begin with that fourth numerical, which says a weightlifter lifted a load of 200 kgf to a height of 2.5 meter in 5 seconds. Calculate the work done and the power developed by him. We have to take G value as 10 Newton per kg. So it's a very simple sum, direct to the formula. We have to just remember that this which is given as the weight, which is the force here, so that is 200 kgf. So I will multiply it with 10 because G value is given as 10 and write it as 2000 Newton. Okay, now I can go to calculate the first one. We have to find the work done. So W is equals to F into S. So this is 2000 and the displacement is 2.5 meter, which is in SI unit. So if I multiply, okay, decimal with will get removed with 1 0, so 25 twos is 50, and then 2 zeros left, this much joule. This finishes the work done. Now the second one is to find the power developed, which is already a very simple sum. Power equal to work done by time. So work done is 5000 divided by the time given is 5. So 5000 divided by 5 will give you 1000 watt. So this was a very, very direct sum. Most of you on your own also must have done it. Now let us take a look at numerical number 5, which says a machine raises a load of 750 Newton through a height of 16 meter in 5 seconds. Calculate the energy spent by the machine, the power of the machine if it is 100% efficient. 100% efficient means it is simply to find the power, and here which the energy spent is there. Remember, work done is the energy is the ability to do the work. So if we find work done, that is the energy spent. Okay, so let us take a look here. So workforce is given there, so I can directly go to write here energy spent is equal to work done, and for work done I can write force into displacement. So force is here 750 and displacement is 16 meters, so we can multiply it out. On multiplying, you will get as 12,000, okay, 12,000 joule. This you get as the energy spent. Now you can go to find the power. So power is equals to work done by time. Work done is 12,000 divided by the time, which is 5 seconds. So you get 2400 watt. So another very direct numerical. Let us now look at numerical number 6. An electric heater of power 3 kilowatt is used for 10 hours. How much energy does it consume? Express your answer in kilowatt hour and also in joule. So we know that power is equals to work done by time, that will be energy by time, so we will be applying that. Okay, so we write here power is equals to work done by time. I can cross multiply. I will get here work done over there, which I can write as energy. So energy, I get it as power into time. Power is 3 kilowatt. I will not change it because we need it in hour, and time as 10. So I get it as 30 kilowatt hour. So this is my first answer. Okay, 30 kilowatt hour. We have to bring it in terms of joule also. Okay, so you must be knowing the conversion that 1 kilowatt hour is equals to 3.6 into 10 to the power 6 joule. A very important conversion you need to remember, and you need to remember it derivation also. Okay, so I will be applying this and get the answer here. So I have 30 kilowatt hour, so that to convert it into joule, 3.6 into 10 to the power 6 joule. (3.6) into 10 to the power 6, this will come in joule. If I multiply 30 and 3.6, okay, so this will remove the 1 0 here. So 3 into 36 will give me 108 into 10 to the power 6 joule. Because we are writing in scientific notation, remember the decimal in this part should be between the first two digits. So I need to bring it 1.08. Now the decimal after 8 has been shifted 2 places. So you need to increase 2 zeros here. So it will become into 10 to the power 8 joule. This is your second answer. Remember to write it in this way if you are writing in scientific notation, decimal between the first two digits. So this numerical is solved here. Now let us take a look at numerical number 7. A water pump raises 50 liter of water. Volume is given. Okay, through a height of 25 meter in 5 seconds, calculate the pump power of the pump used. Efficiency is 100%, so simply we need to find the power. Okay, the information given here is G to be taken as 10 Newton per kg. Density of water is given as 1000 kg per meter cube. So this volume is in liter. Density unit is having the volume unit as meter cube. So we need to convert it into meter cube and then find the mass using this density. Okay, so let us see here how we work it out now. So number 7. So first of all, this volume which is 50 liter, I am dividing by 1000 to convert it into meter cube. Okay, hope you have understood this, because 1 meter cube is 1000 liter. Okay, so we know the volume. Then we know that density is mass by volume. I repeat, density is mass by volume. From there, if I want to calculate mass, I will get density into volume. So I write here mass is equals to density into volume. So that density is given to us 1000 and volume is given to us 50 by 1000. So 1000 is cancelled, we get it here as 50 kg. So whatever was the volume in terms of liter, you get the same mass in terms of kg, because density of water is also 1 kg per liter. Okay, so we know the mass part. The pump is raising the water to a height, so work is done against the force of gravity. So first of all, I write the power formula, work done by time. Because the work is done due to the force of gravity, okay, so I am writing here mgh divided by the time. Now m we have got as 50, g they have asked us to take as 10, and the height to which has been raised is 25. Okay, and then we have to divide by the time, which is 5. Okay, so this is cancelled 10 times, so we get 2 5, and then 10 into 10, so 100, 2 zeros. So this much what is the power of the pump. Hope the sum is understood. Now let us look at this numerical number 8. It will teach you a lot of things, an important numerical. Try to understand properly. The question says a pump is used to lift 600 kg of water from a depth of 75 meter in 10 seconds. So the mass of water is given, the depth can be taken as the height, and the time is given. First we have to find the work done by the pump, that is the easy part. The power at which the pump works, this also you know it. And then you have to find the power rating of the pump. If its efficiency is 40%, efficiency is given, you are asked to find the power rating. Okay, it means when we calculate this part, we will get the what the power output is there. Okay, power rating means you need to find the power input, what power you have to give, so to get the required power which we are getting here. So we will see that when we work out the sum also. So first of all, we go to find the work done by the pump. Okay, so we will go to that work done part, that A part. So work done, because it is lifting it up, again the work done is due to force of gravity, so I will directly use this relationship mgh. So the mass is 600, g value they have asked us to take it as 10, and h is given to us as 75 meter. So you need to calculate it out. First of all, I am writing 3 zeros. 6 and 75 to be multiplied, 6 5s are 30, 0 3 carry, 42 and 3 will give me 45. This much is we are finding is work done, so I will write it as joule. So the A part is done. Let us come to the B part. The P part is to find the power at which the pump is working. So we know the work done, so we write power equals to work done by time. So 4 5 4 zeros, this is the work done, and the time is 10. So 1 0 cancelled, we get it as 45,000 watt, which I will convert here into kilowatt to make the number look smaller. Okay, now comes the main part here. The power rating of the pump, if its efficiency is 40%. Okay, so efficiency formula I will write. Efficiency is equals to power output by power input. You will come across this formula when we do the machine chapter, okay? But now because this numerical has come, so I'm applying it. Power efficiency is power output by power input. So efficiency is 40% given. So in number, it will be 40 by 100, okay? While doing the numerical, we have got what power the pump is giving us. So that becomes the power output. Here it is 45 and the power rating is our power input. So currently I am writing it as power input. So this power input will come here. So now I am just putting it as power rating because that is the word used over here to find out. So I will get it as 45 into 100 by 40. So 0 is cancelled, 2 2s are 2 5s are. So 45 will be multiplied with 5, which I know as 225 by 2. So this will be divided 112.5 kilowatt. So this is the power rating of this particular motor which is working here. Hope you have understood how to apply this efficiency formula and get either the power output or the power input. Now next numerical number 9 is a very short and a easy numerical, but it is having a use of a formula which you all usually forget. Number 9.1, an ox can apply a maximum force of 1000 Newton. Force is given. It is taking part in a cart race and is able to pull the cart at a constant speed of 30 meters per second while making its best effort. Calculate the power developed by the ox. So you are given force and the constant speed is given. You are asked to find the power. So if you remember the formulas which I had given, power formula, one of them was F into V. So force is given here 1000 and V is that average speed. So constant speed is given as 30. So into 30. So that gives us 30,000 watt. If you want, you can write it into kilowatt as 30 kilowatt. So a very direct form sum, only provided you remember this power formula as force into average speed also. Next is a very small numerical, okay. 10th one, the power of a motor is 40 kilowatt. Power is given to you. At what speed? You have to find the speed. The motor raised a load of 20,000 Newton. So this is the force given. So formula relating force, power and speed. So you know the previous sum also was this only. So we go to write the formula, okay. Power is equals to force into the average speed. Power is 40 kilowatt. So I am writing as 40 into 1000 watt. Force is given to us as 20,000. We have to find the speed. So this V will come 40,000 divided by 20,000. So that gives you as 2 meter per second. So this is your answer. A very direct sum, provided you remember this formula. Power is equals to force into average speed. Now coming to numerical number 11, which is again the use of the same formula which we have been using, a direct sum, which you actually could have done it, but still I am showing it, the working of it, because I promised that I will be solving each and every numerical. So Rajan exerts a force of 150 Newton in pulling a cart at a constant speed of 10 meter per second. Calculate the power exerted, okay. So we take this, so we will be applying this formula, same one, power is equals to F into V. So we have here force given as 150 and the velocity is, the average speed is 10. So 1500 watt is the answer. So very simple direct numerical. Now coming to numerical number 12, which says a boy weighing 350 Newton climbs up 30 steps, each 20 centimeter high. So there are 30 steps, each height is 20 centimeter. So the total height has to be calculated, and in 1 minute we have to calculate the work done and the power spent. Okay, so only part here is that 30 steps and 20 centimeter you need to take care of that. So I will be writing here. So I am writing here, that is the displacement which he is doing altogether. There are 30 steps, each has a height of 20 centimeter into 20. This will give you the result in centimeter. I want to convert it into meter to keep it in SI unit. By 100, the two zeros will get cancelled. You will get it as 6 meters. So you know the displacement is, the done over here is 6 meters. So first part I can go to find now. Work done is equals to force into displacement. It is, he is climbing up, so we could have taken it as work done due to force of gravity, but because the force is directly given there, I have applied this instead of mgh. So here it is 350 into 6, so 0, 6 5s are 30, 0, 6 3s are 18, and 3 2100. We are finding the work done, so the unit will be joule. So 2100 joule is the work done. Now we come to the power spent, the second part. So power is equals to work done by time. Work done is 2100. Okay, the time is 1 minute. We need to change it to seconds. So that 1 minute is 60 seconds. Okay, so this is cancelled. If I cancel with 6 directly, 6 3s are 18. So we have 3 left, 6 5s are 30. So I get it as 35 watt is the power spent. So another very easy direct sum, only that step part you have to take care of. Let's see numerical number 13, which will include certain thing which you should remember. As I am doing the sums, I will be mentioning about that. Okay, let us take a look at the numerical. It takes 20 seconds for a person A of mass 50 kg to climb up the stairs. So person A is having a mass of 50 kg, time is 20 seconds, while another person B of the same mass of both the person is same, does it in 15 seconds. The second one is doing in 15 seconds. Compare the work done in first case, and in the second case power developed by the person A and B. This part, compare, whenever compare will be there, you will be writing the answer in terms of ratio. It is compulsory. The board suggests that only comparison is to be done in terms of ratio. Okay, so work done part over here, you see he is climbing up. Okay, he is going up. So work done due to force of gravity will be there. So force of gravity is mgh. Work done due to force of gravity is mgh. So I will write here mgh. Now you take a look, m is same for both, g will be the same, and height which is there is the same because they are climbing up to the same place. So work done for both the person A and B will come the same. So I will write it like this first. Work done by A by work done by B will be 1 by, or I can write it and show here, mgh by mgh. So both will get cancelled. So it means I will get work done by A is to work done by B as 1 is to 1. Okay, both of their work done is the same. So this was the first part. Now the second part is the power, compare their power. So I will write here PA by PB, that is the power of person A to the person B. Okay, so that will be, I have to divide the work done by the person A by the time taken by that person. Okay, and the work done by the person B by the time taken by the person. Work done ratio is the same. So I can represent for both of them as W by time taken by A, W by time taken by B. Now, work done for both of them is same, so is cancelled. So if I write it in fraction, this time taken by B will go to the numerator part by time taken by A. Time taken by B is 15 seconds and this one is 20. Reduce it, 3 and 4. So we have got 3 by 4. So we need to write it as ratio. So power spent by A to the power spent by B is 3 is to 4. So This is my answer to the second part, and this is to my first part. Do remember, again I repeat, comparison is asked, will leave your answer in terms of ratio. So let us come to now this numerical 14, which is also based on comparison. So we will be finding the ratio, the answer we will keeping it in ratio. So let us see, a boy weighing 40 kgf climbs up a stair of 30 steps each 20 centimeter high in 4 minutes, and a girl weighing 30 kgf does the same in 3 minutes. We have to compare the work done by them and the power developed by them. So we have to relate their work done and their power. So let us see the working of it. So one is a boy and the other is a girl. So I am writing here work done by the boy divided by work done by the girl. So that will be the weight of the boy itself, in a way, is the force which is being involved over there. So I will write force of the boy, that is the weight, into the displacement done by the boy, and force of the girl into the displacement of the girl. Okay, so force here is 40 kgf. I will not try to bring into Newton because the other one is also in terms of kgf. Okay, so I am writing here first of all for the boy, which is 40, and the displacement will be 30 steps of 20 centimeter each. So I can do 30 into 20. Now for the girl, the weight is 30 kgf and the same height is being covered by both. So this remains the same. So what you can notice here is that 30 cancelled, 20 cancelled, 0 cancelled, 4 by 3. So I can go to right now work done by the boy is to work done by the girl is equals to 4 is to 3. So that's the benefit of not converting, not required. Same units are given. We have to find the ratio. We can deal in this way. Now this was the first part. Now come to the second part. That is the power developed by them. So power by the boy divided by the power by the girl. So that will be the work done by the boy divided by the time taken by the boy, and then work done by the girl divided by the time taken by the girl. This I can write as WB by, that is work done by the boy by work done by the girl, into the time taken by the girl by the time taken by the boy. So this part we already know is 4 by 3. Time taken by the girl is 3 minutes. So into 3 year, and by the boy was 4 minutes. So 4 year, 3 cancel, 4 cancelled, I will get 1. So I will write here the ratio of their power as 1 is to 1. This is my answer. I hope you have understood how to relate when you have to find the ratio. Remember, if the units are same in both the place, no need of doing any conversions. Now we look at numerical number 11. Here also we have a comparison part, but we have to calculate also. A man raises a box of mass 50 kg to a height of 2 meter in 20 seconds, while another man raises the same box to the same height in 50 seconds. So this part 50 kg and the height is the same for the second one also. Okay, we are asked to find the compare. Compare is the first part, the work done and the power developed by them. We have to compare first, and the second part is telling us to find their work done and the power developed by each man. So here is the calculate part, here is the comparison part. So I will go by this, that we calculate first and then find the comparison. Okay, so first of all we are calculating the work done. Okay, so work done here for the first person, so I am writing it as W1, and we will be using mgh because the things are being lifted, so we can find the work done due to the force of gravity. For the first one, the mass is 50 kg. G, they have asked us to take it as 10, and the height is 2 meter. So 5 2s is 10 and then 2 zeros, so that much Joule is the work done by the first one, and the other man is raising it to the same box to the same height. So work done by the second one also remains the same as W1, and that comes as 1000 joule. Okay, so we have calculated the work done by both of them. Okay, so that is the B first part we have got here. Okay, now to the second part is the power developed by each man. So I'm writing for P1 will be W1 by the time taken by the first one. So 1000 divided by the time taken by the first one is 20 seconds. So 1000 divided by 20 will give you 50 watt. So this one is done. Okay. Then for the second person, W2 by T1, work done is the same 1000, but the time taken is different, which is 50 seconds. So 1000 divided by 50 will give you 20 watt. So we have done the calculation part. We know the calculation, so we can find the A part of comparison easily. So in the A part, we have to compare the work done. Okay. So work done by the first is to the work done by the second. Both of their work done at comes as 1000 joule. So 1000 into 1000, that you get it as 1:1. So that was an easy part. This was the first part of A part. Now we go to the second one, which is the comparison of power. So P1 by P2, W1 by T1 and W2 by T2. You know that the ratio of the work done is the same. Okay, 1:1. So in a way we can cancel it, or we can write W1 by W2 into T2 by T1. So W1 by W2, 1 by 1 will be written as 1, and time taken by the second one is 50 and the first one is 20. So 50 for the second one, 20 for this one. You can reduce it, which is a simple reduction, and you get it as 5:2. So we have compared them. We finally come to the last numerical of this part. Okay, number 16th one. Again, here it is the calculation and comparison sum. A boy takes 3 minutes to lift a 20-liter water bucket from a 20-meter deep well, while his father does it in 2 minutes. So the time taken by them is different, but the work is done same. Okay, compare the work and the power developed by them, how much work each does. So here calculation is there, so we will better do the calculation part first. Density is given because here the volume of water is given, not the mass. And then G value here is 9.8. First numerical getting in this part where G is 9.8, not 10. You have to be careful about these things. So coming to that 16th one now. So first of all, we'll go to calculate the work done by each of them. Okay. So for that, this volume part has to be related. So I'm writing volume is equals to 20 liter. I want to convert it into meter cube. So by 1000 meter cube. Okay, then I will go to find mass. Density is mass by volume, so mass will be density into volume. So I write here mass is equals to density into volume. So density is given to us as 10 to the power 3, which is 1000 into 20 by 1000. So I get it as 20 kilogram. So I know the mass as 20 kg. Now first of all, I will find the work done by the boy. So I am writing as B. So I will be using again work done due to force of gravity, mgh. So 20 here, G is 9.8 and the height is 20 meter. So 10 will be used in removing the decimal. So 10 I will write here. 2 2 is 4 into 98. 4 8 is 32. 3 36 and 3 this much joule is the work done by the boy. The father also does the same work. Okay. So I will write here work done by the father is equal to the work done by the boy, 3920 joules. So the work done by both of them is the same thing. So this we were calculating was the B part first. Now we know their values, we can go to find the power and the work comparison. So we go to do the first part here. Okay, this was the second part we started first. So we have to find the compare their work. So I'm writing here work done by the boy is to work done by the father. Same work is being done. Okay, so 3920 is to 3920 equals to 1 is to 1. You could have written directly 1 is to 1 also, no problem in that. Okay, now we will find the ratio of their power. So for the boy first, then the father. So work done by the boy divided by the time taken by the boy, work done by the father divided by the time taken by the father. So this I will get WB by WF into TF by TB. So this over here, both of them work done is same. I am cancelling it. Time taken by the father was 2 minutes and for the boy was 3 minutes. So 2 by 3, both are in same unit. So we need not convert it into seconds. So I am getting 2 is to 3. So I can write the ratio now as 2 is to 3. So with this we come to the end of this numerical of work, energy and power first part. Very soon I will be coming up with the other part numerical of this chapter. I hope you have understood the numericals. Work it out on your own also. Do remember to subscribe my channel, like the videos, comment on them. Okay. Thank you for watching it.